So we want to solve for the natural number n if 2 to the power of n plus 4 is a perfect square. But before we do that, please consider subscribing for more content like this and hit the like button if you find this video helpful. So let's say that 2 to the power of n plus 49 is equal to something like a squared, where a is an integer. So we wanted 2 to the power of n plus 49 to be a perfect square, so we set it equal to a squared. And now, let's go ahead and subtract 49 from both sides to get 2 to the power of n isolated. So 2 to the power of n will equal a squared minus 49. Now, notice that 49 is a perfect square, therefore we have a difference of two squares on the right-hand side. Therefore, I can factor the right-hand side as a minus 7 times a plus 7. Now, notice that on the left-hand side, we have power of 2. We only have power of 2. We don't have power of anything else. Therefore, this factor and this factor must be powers of 2. Because if they were powers of something else, then we would have to have those powers on the left-hand side as well. I hope that makes sense. So let's go ahead and say that this is 2 to the power of k. Therefore, this one has to be 2 to the power of n minus k, because once these two are multiplied, we will have 2 to the power of k plus n minus k, which is equal to 2 to the power of n, which is what we have on the left-hand side. So we can say that a minus 7 has to equal to 2 to the power of k, and a plus 7 has to equal to 2 to the power of n minus k. Now, let's go ahead and say that this is equation number 1, this is equation number 2, and let's go ahead and subtract number 1 from number 2 to get a plus 7 minus the quantity a minus 7 equals 2 to the power of n minus k minus 2 to the power of k. So we will have 14 on the left-hand side equals 2 to the power of n minus k minus 2 to the power of k. So we can go ahead and say that 2 to the power of n minus k minus 2 to the power of k is something positive. Therefore, 2 to the power of n minus k is greater than 2 to the power of k. So I'm going to go ahead and factor out 2 to the power of k on the right-hand side. So we'll have 14 equals 2 to the power of k times 2 to the power of n minus 2k minus 1. And then we can go ahead and factor out the left-hand side. So we have 2 times 7 equals 2 to the power of k times 2 to the power of n minus 2k, and then minus 1. Now, notice that this is even, and this is odd, and this is even, while this is odd. Therefore, we can say that 2 to the power of k must equal to 2, and 2 to the power of n minus 2k minus 1 has to equal to 7. So from the first one, we'll have k equals 1. And if we add 1 to both sides in the second one, we will have 2 to the power of n minus 2 equals 8. And 8 equals 2 cubed. Therefore, n minus 2 has to equal to 3. Therefore, n has to be 5. So, n equals 5 is the solution for our problem. And this brings us to the end of this video. Thank you for watching this video. Please consider subscribing for more content like this, and hit the like button if you find this video helpful. Hopefully, I will see you later. Goodbye for now.